Problem number 35. In a particle accelerator, an electron enters a region in which it accelerates uniformly in a straight line from a speed of 4 multiplied 10 power 5 meter per second to a speed of 6 multiplied 10 power 7 meter per second in a distance of 3 centimeter. For what time interval does the electron accelerate? So in this question also, we are going to find the time value, but first of all we have to write what is given in the question. So initially the electron has the initial speed vi, which is equal to 4 multiply 10 power 5 meter per second, and then the final speed vf, which is equal to 6 multiply 10 power 7 meter per second, and then the distance is given here as 3 centimeter. We have to convert this centimeter to meter. By that you will get 0.03 meter. So now what we need, we have to find the answer for t. But if you want to find the answer for t, first we need the acceleration. Why? Because let's see what's the equation we have in our hand. First equation is v final equal to v initial plus at. Second equation delta x, which is equal to v initial t plus half at square, and the third equation is v final square, which is equal to v initial square plus 2 into a into delta x, right? If you see these three equations, we have acceleration. That means if you want to find the time, first we need the value of a. So what we have to do, I'm going to find the acceleration first, and then we have to find the answer for the time. So for this, you can see there is no time, so better we can deal with the last equation, which is v final square equal to v initial square plus 2 into a into delta x. You have to rearrange this equation in terms of acceleration. Therefore a equal to v final square minus v initial square divided by 2 into delta x. So I have to substitute the value here. Your v final value is a 6 multiply 10 power 7 whole square minus your initial speed is 4 multiply 10 power 5 whole square divided by 2 multiplied by 0.03. Let's see what will be the answer for acceleration. So 6 multiplied 10 power 7 square minus 4 multiplied 10 power 5 square divided by 2 multiplied by 0.03. I got the answer here as 5.9997 10 power 16. So what's the answer I got? The answer I got here as a equal to 5.99 multiply 10 power 16 meter per second square. Or if you want to round out the number, you can just go ahead, or you can use the number as it is. Clear? Actually we have 3 nines here, so better we can use as it is what we have in our hand. Clear? So I have to use this value. Now by using this, again we have to use the first equation. So v final we have, v initial we have, acceleration just now we got. By using this we can find the answer easily. Clear? So I am going to deal for finding the time. I am going to use the first equation. If you use the first equation, v final equal to v initial plus a multiplied by t, we have to rearrange this equation in terms of time. Therefore time equal to v final minus v initial divided by acceleration. Now I have to substitute the value here. V final, let's we just go back to see the value. V final 6 multiplied 10 power 7 and v initial 4 multiplied 10 power 5, and acceleration just before we got as 5.999 multiplied 10 power 16. So I'm going to use this value here. So we have to substitute the value here as 6 multiply 10 power 7 minus 4 multiply 10 power 5 divided by the acceleration 5.999 multiplied 10 power 16. So let's see what will be the answer for this time. 6 10 power 7 minus 4 10 power 5 divided by 5.999 10 power 16. I got the answer as 9.934 9.934 10 power minus 10 second. So this is the answer for this question. Thank you.